All right, welcome to CPS Systems, and today we're going to be looking at a comparison between the CPS bracket system and pole barn kits and the Perma-Column system. If you're a DIYer, you're going to save time and money doing this, and you're going to build a better building. And if you're a contractor, this is definitely for you too. All right, let's look at wind shear. Wind shear is the forces that hit your building and pull it up out of the ground or flop it over and on its side. Now, CPS uses a massive double-sized bell auger to create this bell footing, okay? So you've got a bell footing that might be 12 inches on top and 24 inches on the bottom. So it's twice the size on the bottom than it is on the top, or it could be 18 inches at the top and 36 inches at the bottom. So you're gonna have a massive advantage over what Perma-Column does is put a 6 to 4 inch column that goes straight down into the ground that is solid and straight and has maybe just a little angle iron to try to hold it in. Okay, but the forces of wind are massive. You're creating a huge sail that's, maybe 10 to 18 feet high and 20 to 60 to 80 feet long. So it's got to be able to handle a massive amount of force from the winds. So let's look at an actual case study of a farmer in Oklahoma, and we'll put this video link in the description of this movie, and you can see these are Perma-Column columns. So before you invest, take a look at what this farmer experienced, see his equipment that was damaged, see his investment, his building gone, on all the time and labor wasted. If he put up this building by himself, time and wasted labor. Now, I want to point out a few things. Look at this here. This is a massive gap. This has been moved back and forth, back and forth. You can see that post moving back and forth in the wind at some point in time, causing this hole to happen because the whole column was not stable. Imagine a 24 to 36 inch base trying to move in virgin soil. It's just never going to happen. Our buildings have been hit by tornado gusts and shear force winds that way exceed the 30 mile an hour that brought this building down. Look at the damage. The concrete is broken. The rebar is snapped off the base in several points, and the concrete is just shattered into bits. It's completely useless at this point in time, and we'll discover why that is. Now, look at this. We noticed that on the other side, it was moving back and forth. Here, it just pulled straight up out of the ground. Again, this thin, smooth concrete is almost no resistance to that up force that we were looking at here. They have these tiny metal angle brackets down at the bottom that are supposed to resist all this force, but you can see just got pulled up straight through the soil. If the soil is at all wet or loose or loamy, you're going to have all sorts of problems. These are the splash boards, just popped right off, and you'll see more about the splash boards later. Here, they're actually bolted into the point of where they fail due to it degrades the concrete with having nails and things being driven straight into them. And you can see again, the rebar is completely disassociated because they're just spot welded onto the bottom of that bracket. And you can see portions of the concrete just blowing to bits and just 30 mile an hour wind. The New Holland tractor damaged all of his equipment inaccessible under this, and you can see the new steel. This is the side of the building, not the roof, is collapsed down on top of the equipment, causing all the damage. Just should never have happened. Let's look at the details of these brackets a little bit more closely. So you can see up close here the slide, and I'll explain what's going on here. So this is a CPS bracket, and it is a different design. It's a patent design that has two solid sides that are independently cut out of the steel, and then they're welded here to a third base. And you think, oh, that looks an awful lot like this bracket, but the difference is this is a bent shape U, and that bent shape U is transferring all of the force back and forth. Just as when you bend anything and it goes back and forth, you're going to eventually shear the metal. Now, imagine shearing a solid piece of 1/4 inch steel. It's going to flex because it has tensile strength, okay? And the welds are here along the edge of the rebar, and so the rebar is going to flex with that tensile strength of steel, which is natural to steel, but the tensile strength is working against you. That flex is going to work against the solidity of the concrete and cause it to break and cause the spot welds of the rebar to just snap off the bottom of that bracket. So this is an example. This is actually a photo taken from a University of Wisconsin study. So this isn't just us making this up. An actual University of Wisconsin stress test was taken, okay? And according to this in-depth research article, this is an engineering research article that we could link to in the notes of this video. Here's what they said. They said if a U-shape with a thin base is created, as is done with Perma-Column, a very significant problem develops when the bracket is placed under a bending load, like wind. As the U-shaped object is placed in bending, it will attempt to straighten, as metal does, and it transfers the applied load. This attempt to straighten crushes the concrete or buckles the steel, and ultimately renders the column useless, which is the verdict of this study of the University of Wisconsin. So you could choose to have this patented brute force bracket holding up your building, or you can use something that, according to the University of Wisconsin, has some fatal flaws in its engineering. So if you're a contractor and don't want to face this or those other pictures, please consider using Concrete Pier System. If you're a DIYer, you've come to the right place to find out where you can find a permanent solution. Now, here's another advantage: shipping cost. Why should you pay for the shipping of concrete across the country? A local concrete plants, so that you don't have to face that across the country. Okay, now here you can see a few other details. The welding of our rebar to this one solid piece of vertical steel. And this part of the vertical steel actually goes below the level of the concrete. And then you see clearly the clip that doesn't provide any structure, but it provides an expeditious way for you to just slide that onto the mounting clip that's already on the splashboards, and everything is leveled on the splashboards. We'll get into that in a bit, but so shipping cost is far less for this. Now, installation time. People think, you're often comparing apples to apples, and you're thinking, oh, I'll just compare the price of one to the price of others. Well, ours is cost less, but the labor involved in this is significantly less in the CPS system. Okay, so that's something else you need to consider in the overall system. So let's look at that labor cost. What does it take to install this system? Yes, you have to level your splashboards on the line vertically using your laser levels. You do have to dig a concrete pier, or you have to auger on this side as well. So both require augering. And then ours requires pouring concrete into this system. So that's an extra step, but it takes you all of 5 seconds to just slide that bracket into the clip that's on the splashboard, and it holds it in place. And it's very simple. Imagine the labor here. So you've got two individuals minimum here, and one of them driving a skid steer with forks just to place this thing to place. So he's nudging it from the side. So he's doing all these awkward skid steer maneuvers to get that thing to get vertical. And it's going into a post, and then it's got to slide down in there. And then it has to be backfilled. And we'll just talk about what it's like to handle a 200-pound piece of equipment versus a 25-pound bracket, and the speed in which the installation takes place. And again, imagine doing this in different weather conditions. Ours can be installed in dry and wet weather. You need some sort of a lift. You're going to need a lift for doing all the framing. So it's going to preclude you from doing this in really wet conditions. Can you imagine doing all the sloppy backfill to try to keep that 200-pound post from flopping in the wind? Heaven forbid there's wind and rain. It would make it impossible. Wind isn't going to affect your installation, and the CPS system putting in the brackets. So it's a much more friendly system to if you're a contractor and has to deal with all types of weather. Okay, pricing. Ours could be $60 and $68 per kit versus $200 per kit. So not only are you going to save labor, but you're going to save just upfront costs in the kit, because we're not having to ship tons of concrete to you over land, and it's not already precasting all of that concrete in addition to the steel bracket and all the welding that they have to do. Okay, let's look at downforce. Okay, now if you're engineering your building and you're needing to put in a large span door or a large span maybe an 80-foot wide building, a 60-foot wide, well, you're going to have a lot more downforce. So with the downforce of a Perma-Column, you've got maybe 6 inches of downforce at the bottom of that. And they'll say, well, we'll put a pancake down at the bottom. So they'll put like a 12-inch disc at the bottom that can slop around in the rain and the wet and the muck at the bottom. Maybe backfill it with some concrete, maybe. But look what happened to this one. The downforce wasn't there, and the upforce wasn't there as well. You're talking, again, 4 times the downforce here. So if you've got a 12-inch top, you can have a 24-inch base. So according to engineering, you can put 4 times the force on that pier than you could on that pier. So it's a much stronger pier from the standpoint of downforce. And lateral support, it gives you much more lateral support. See, you can see the gapping behind these on these walls on the Perma-Column that went back and forth just like a twig in the ground and just wiggled its way straight out and pulled straight up in the wind. Try wiggling a 24-inch CPS column. And we actually have an auger that you can buy that fits on a skid steer, and in 5 to 10 minutes an experienced user can dig out a belled auger, and it will pull all the dirt into it, and you can take all the dirt straight out of it, and you're going to have a clean belled auger hole in just a matter of minutes. So we've thought of everything in this. So we don't have the columns to show you because these things weigh, several tons worth of concrete versus something 200 pounds you can lift in with a couple of people. So it also prevents heaving. So that's what's great about this, is if you live in the south or places where there's heaving soils, you can get your pier actually down beneath the heaving level and fan it out with that bell and prevent heaving both from frost and from expansion soils. So otherwise the frost can get a hold of this and start over time heaving up these posts. I've seen posts on my farm where I stuck it in and over the course of 15 years, it's 3 and 4 inches up out of the ground now. So if I had done this, those are just fence posts, this would never move, I guarantee, for years, not even a half a quarter inch. So center notched wood columns. So this is another brilliant thing that CPS has to offer here for this. You see the notches on the top of these columns. So the benefit that CPS has with this is that because we're so accurate in the positioning of our columns, we're not digging a hole 4 feet in the bottom, and the bottom of that 4-foot hole is going to be the determining factor for the top of our building. We don't have to put double joists on the top to measure or to hide all the slop of our building. We're so precise that you can put your joists straight into the top of our columns that we provided in our pole barn kits. And then you can lag bolt right straight through there. And the strength of that joint of the truss in a joint like this is immense versus a truss standing on top of a double header system, much weaker. So again, another strength and another time-saving device and another accuracy device that's going to build a better building. Okay, that's what's so important about this. Installation process. So this is framing. Again, we're looking at forks. We're looking at 2 guys. Over here, yes, if you can frame on the ground and then lift your walls into place. So your installation process is going to be markedly faster. You can do in one day the entire foundation with just a couple of individuals with a CPS system versus multiple people that you need to do. You need to use the jobber tool, the shovel, the back and forth with all the dirt. And that's once you've done your augering, you poured your concrete. The leveling process is simple. You can just put your level against there. You've got wet concrete. You wiggle it just a little bit into place, and then boom, it's level. Versus you're looking at this, where you're looking at trying to move a 200-pound system back and forth, where all of our leveling and vertically and horizontally has already been done with the splash boards. And we'll talk a little bit about that. Okay, let's look at the splash boards. Now, their splash boards have nothing to do with the structure. They've been bolted on the outside, and heaven forbid again that you hit any of the rebar on the inside when you're bolting that angle iron on there. And again, they're shipping heavy concrete to you across the country, and it's got to have rebar and how brittle that is and it's attached to this joint here. Now you've also got another weak joint there, where it could come apart, and you could have penetration from insects and animals. Okay, and whereas ours is a solid piece of fiberglass encoded board that is guaranteed for the lifetime of your building. Okay, now here's a joint that we're showing here, and this joint is going to have this temporary metal brace here because we're going to place that joint right over a concrete column, and a bracket is going to be holding that together, and it's going to be a solid joint in that building. Now you're thinking that this is a composite material, which it is, and it's rot proof. For hundreds of years it's not going to rot, but it also doesn't expand due to the fiberglass wrap around that. It's structural. It's as strong as a structural board because of the fiberglass, and it's not going to, even over a 30-foot span in the summertime, it's not going to grow more than 1/8 of an inch. So it's a great material that only CPS has versus other solutions that people are trying to get that are rot proof but are just heavy, awkward, and what are you going to do? Cut that with a diamond blade? That's just nuts. Versus the ease of use with this kind of material. Okay, backfill. Okay, so the quality of the backfill, and like again, we mentioned the jobber tool and the shovel. You do have to backfill a little bit, but the goal is just to keep it from mushrooming out of the top of the sonotube. This is going to go down into virgin soil. The concrete is going to be solid, and you're not really worried about the backfill around the base of this. You have reusable concrete forms and sonotubes that you can use once. Okay, so you're looking at a significant amount of labor over here and very little labor to backfill this. And you can see in here there are bolts that come out from the clips that will anchor your splash boards into the concrete pier itself. Okay, so height issues are really not an issue here, so you can build off-grade, and I'll show you a little bit more how high off-grade you can get, but you're going to use your laser level to level your splash boards. So the entire system of CPS is built around the splash boards and not around the bottom of the hole. Okay, you're not going to use your auger to set the level of your building. You're using the splash board. So you build this beautiful level perimeter using this robust reinforced fiberglass composite board, and you can get that very highly accurate both vertically and horizontally. So, and you place your brackets, your clips, your easy mount clips on this pre-leveled splash board so that you can easily mount those clips later on. Then you can come along later and you can do all of your framing from our CPS building kits on the ground. Okay, so you just lay down the columns next to at the base of each one of our brackets so that they'll be easily turned up into place. And then you can do all your framing here, horizontally framing. Imagine the speed that you can get in doing all of the framing on the ground, and then just turning the gable and the eave walls up with maybe your crew or with a couple of skid steers. You can get that vertical in just a few minutes. Versus these already being bolted in place, you've got to nail all of that in you have to do all of your framing horizontally from the ground up. So eventually you're going to be on ladders, you're going to be on lifts. That's going to preclude you doing this in the rain. And they've got these other blocking things that they're doing in between here, so that you can nail down into the boards on the bottom. So it's just a lot of additional labor that you don't need to do. Again, saving you time, making a safer way to build a building and a faster way to build a building. If you're by yourself, this is doing DIY. This is going to be a much easier way to do construction. So you've got off-grade issues as well here. So we're showing you us building a building about 3 feet off-grade. So you can use longer pieces of sonotube, and you can it's not a problem. You can continue to drop our belled auger holes down deeper if you need to. So you could have a 6 foot or a 7 foot post if you needed to, and you could build off grade and then just backfill with gravel and make your whole system secure. And if you wanted to, you're going to have a nice level platform after the fact, or you can grade all this before and do it all on grade. But what's great is that you don't, as a contractor, you can get in there very quickly and build on about any grade and get your building done quickly. Okay, so that's another great advantage with CPS. Now, you're not going to be worried about your backfill. with our system. Like I said, this is based on the solid soil, virgin soil down below. This is completely based on the sand, the grade, the clay that you're encountering. It could be loamy soil. And then what? You're tossing loam down at the bottom. Well, then you're going to use gravel, and so you're going to bring in all this gravel, and then you're going to make a French drain for the bottom of your building. So all in all, you can see that the CPS system is a lot better than the Perma-Column system. You're going to have a stronger system. You're going to have a better building. You're going to have a firmer foundation. You're going to have a longer lasting building, and you're going to build it for less money, and you're going to use less labor. So there are a lot of reasons why the CPS system is much better than Perma-Column. And we invite you to give us a call, and we'll talk through all the details that you need to know in order to get started with the CPS building kit system and the CPS brackets. So whether you're a DIYer or a contractor, give us a call, and we'd love to help you out getting started with the CPS system today.